myself Yamchan from the Basic Science Department, which is Computer Science and Engineering from the section PMW, and from the College of Sri Venkateshwara College of Engineering, Bengaluru. And today's my topic is conduction of heat in the subject of mathematics. And let's move on to the topic. The whole section, the topics to be explained is the introduction, the heat conduction, and the boundary conditions, and the heat equation, and the conduction steady condition, and the transient heat condition, and the heat transfer in multi-dimensional system, and the application of heat conduction, and the analytical and numerical solutions, and the last one is the conclusion and the future directions. Let's move on to the first topic, which is we begin with the heat equation. The heat equation is the partial differential equation that describes the heat distribution over time. It is typically expressed as dou u by dou t divided is equals to alpha is delta square u, where u is the temperature, t is time, and alpha is the thermal diffusivity. And this equation is fundamental in analyzing and transient and steady state heat conduction problems. And this is the heat equation. Let's move on to the topic, which is the introduction to heat conduction. Introduction to heat conduction is the process which the heat energy is transferred through the metal, and it primarily occurs in solid where the particles are closely packed together. Understanding the heat conduction essentially for applications in engineering and material science. And the conduction means the conduction is the transfer of heat to the metal or the material by the direct contact. And this is all about the heat conduction or introduction to heat conduction. Let's move on to the topic, boundary conditions. The boundary conditions are the crucial for the solving the heat equation in partial applications. Common types include the Robin boundary conditions and the Rayleigh-Neumann conditions, and these are all the common types condition which includes, and these conditions specify temperature or heat flux values at the boundaries of the metal. And this is all about the boundary conditions. And the first main topic is which is one-dimensional heat conduction, where the heat is passed through the one-dimensional systems. It is also called as 1D heat conduction. And the one-dimensional heat conduction simplifies the analysis of heat transfer in rods and bars. The governing equation reduces to dou u by dou t is equals to alpha dou u square by dou x square for a rod of length. And solution can be obtained using techniques such as the separation of variables or the Fourier series. And this is all about the 1D heat conduction. And let's move on to the another topic, which is steady state solution. Steady state solutions occurs when the temperature distribution no longer changes with time. Under steady state conditions, the heat equation simplifies to the delta square u is equals to 0. This leads to the linear temperature profile in simple geometrics like inserted bars. And this is all about the steady state solution. And let's move on to the another topic, which is transient heat conduction. Transient heat conduction involves the time and the dependent temperature changes in material. The solution requires initially the conditions and often results in more complex temperature profiles. And the numerical methods like finite difference or the finite element methods are frequently used for the analytics. Through this diagram, we can understood that the T is increasing when the T1 is greater than T2. And this is all about the transient heat conduction. Let's move on to the another topic, which is heat transfer in multi-dimensional system. Before we saw that the heat transfer in 1D dimensional system, which is one dimensional system, and now we are seeing that heat transfer in multi-dimensional systems. Multi-dimensional systems are the heat conduction that consider heat transfer in two or more three dimensions, like two or three dimensions. The governing equation remains similar, but the incorporate partial derivatives in multiple spatial dimensions. Analyzing this, systems requires advanced mathematical techniques and computational tools. And the heat conduction equation when the heat transfer in multi-dimensional system is given by Q is equals to Ka into Tb minus Ta by d. Here we can see that the Q represents the heat flow rate and the K is the thermal conductivity, A is the cross-sectional area, Ta and Tb is nothing but the high temperature region and low temperature region, and the D is the thickness of the material what we have taken. And this is all about the heat transfer in multi-dimensional system. Let's move on to the next topic, which is applications of heat conduction. There are so many applications of heat conduction which is we go through in daily life, and the some of the main applications which come a part of our life is the heat conduction principles applies various fields including electronics, building materials and thermal insulation. Engineerings are use this principle to design systems that may manage heat efficiently to enhance performance and safety. Real world application includes heat exchangers and thermal barriers and electronic cooling system. Here we can see by the diagram they are given three radiation, which is conduction, convection and radiation. Conduction is the transfer of heat from one substance to another due to direct contact. The convection is the transfer of heat through a fluid caused by the molecular motion. And the radiation is the energy that is radiated in the form of rays or the waves or the particles. And this is all about the applications of heat conduction which is given by me. Next one is the analytical and the numerical solution. Analytical is nothing but the solution provide the exact answer for the simply for or the geometric and the boundary conditions. However, the many real world problems are too complex, necessitating the numerical methods for approximate solution. Understanding the both approaches in vital for engineering to model heat conduction accurately. Here, the numerical solution is nothing but the techniques by which the mathematical problems are formulated, and so they can be solved when the arithmetic can be logically operations. Here we can see through the diagram the numerical analytic. In the numerical we can say that approximate value. In analytically we can say that exact or easily coded or not so easy, see to get and not so easy. These are the main differences which we are seeing, that numerical versus analytical solutions. And this is the whole about the analytical and the numerical solutions. Let's move on to the another topic, which is the conclusion and the future direction. The whole thing is the conclusion of this topic is the study of heat conduction is crucial in modern technology and engineering application. Advances in material sciences and computational method and continue to expand over the understanding of heat transfer. And future research may focus on nanoscale heat conduction and an innovative material for improved thermal management. And this is all about the heat conduction of heat. Thank you very much. Have a great day.